I am so very sorry about the stream problems I've been having the last 2 weeks. I don't know what's going on. The last stream crashed, and then this one before we even started crashed. And I am going to try, I guess, to send out social media stuff really quick about the stream having crashed. So you're gonna have to forgive me for wasting a little bit of time right at the beginning here again, trying to let everyone know the new stream URL. It's so frustrating. Like, I wish Restream would like keep the stream alive for me for a second when it crashes, so that I could reestablish at the same URL, but like it crashes and now I have a whole new URL that I have to try and distribute to everyone after, like, you know, carefully coordinating when I'm going to send out all of those messages. Okay, so let me find the new URL for this stream, and I'm going to share it in Discord to hopefully get all of the folks to switch over here. Where even is my Discord? All right, I got. Oops, I even put that in the wrong the wrong Discord server. Jeez. Okay, so hopefully we'll get over to the right place here. I see some people are showing up, and there's some icons hanging out in stream, which is awesome. Bouncing all around there. Thanks, guys, for coming. Give me another like minute to try and fix. Try and send out to social media all the places that I have crashed this stream. Okay, let's get on Twitter and Facebook. Of course, I like closed Twitter and Facebook in preparation for the stream because I'm like, I don't want to have too many things open. I don't want anything to crash this stream. The last stream crashed. This stream needs to not crash. Okay, so we will say stream crashed again. Sorry. Here's the new URL. And it's going to be a good stream today, I think. I really think so. If we could get past having everything break always. Not always. You know, we've done 20 streams. 20 streams! Can you believe we've done 20 streams? And we've had 2 of them where things crashed. And that sucks. Let me find the original tweet here. I'm going to get onto Facebook. I've been resharing my stuff into the Godot group, which is probably the biggest source of people coming to watch the stream from Facebook, is the Godot group on Facebook. Come on, where is... Facebook is not making my panic social media posting any easier. Now I have to find my post. Okay. I don't know. Hopefully some people find their way over. I see a couple of people on the little icons. Let me go see how many eyeballs we got over in Restream, which also seems to have crashed. My browser tab with Restream crashed. Everything is crashing today. Okay, we have 4 eyeballs. Hey, Ross. Good morning. Thanks for coming. All right. So, thank you everyone for coming to this 20th stream. I'm David Snowpack from Snowpack Games. Today we are going to be continuing work on our deterministic physics engine using fixed point math, the goal of which is to be able to use this deterministic physics engine in Retro Tank Party with its new rollback and prediction netcode. This is going to be an exciting one. We are going to actually be working on what I think is the most important function of our physics engine, which is going to be the replacement for the move and slide function that you would normally use in Godot with the Godot physics engine. Let me get rid of all of our, oop, not you guys. Okay, I got the music out of there. I gotta remember all the keys I made for these things. So clock is not C, T for time, there we go, and L for those things. And we gotta get rid of the background, make it, what's the button, make it green. There we go. All right, so on the last stream, someone had a comment that it was exhausting watching the stream with all the little people flying around. And I watched the stream, and I think that's kind of a valid complaint. But I really love this thing that we made, so I'm going to try using it over the stream again this week. But you guys let me know. Let me know in the comments if you think having the little dudes floating over the stream, which it does not appear to be working. What's going on here? It's just making everything all black. Today is a day of technical difficulties. Stream tools debug. Okay. Show it. Nope, you're just making everything black. Chroma key. I got the chroma key turned on here. Maybe we're not going to be having our little guys floating on the screen because it's not working. Oh, that is so frustrating. Oh, you know what? It's probably not working because I'm not showing it. Okay. So I'm going to go turn it on in OBS. And then I'm going to have this show the green guys over it. And you guys are going to have to tell me in chat right now if it's working. And then later, if it's too weird or too annoying to have the guys floating up there. Of course, Restream crashed over here too. What a day. What a day. I hope everyone else is having a good Friday. Let me know how your Friday's going. Are you having loads of technical difficulties and annoying problems like me? All right. Do you guys see the characters floating over the screen, or do you just see blackness? I need to know. I guess I could check on one of my devices. It's a race now. It's a race to see, can I open YouTube on my phone before or after the stream can tell me in chat if the stream tools are working or not. By the way, for anyone who's new to the stream tools with the guys floating around saying the chat messages, that is something that we built together on stream a couple of weeks ago. The characters are visible, Ross says. Ross won. I didn't even manage to type Snowpeck into YouTube. The clean's got a halberd and a shield. Let me see. Ooh, yeah, you're looking good. You're looking good, the clean. What did I get? I am a naked guy with horns. Awesome. That's how I feel right now. Exposed, but still like a little bit confident enough to wear those horns. All right. So, where was that? All right. So last time, we only got through, we were working on trying to get kind of all of the dots connected, picking back up on our physics engine, and we were trying to get this demo working, which has this little tank icon moving back and forth and changing color when it collides with a shape. And at the end of the last stream, we almost had it working very nearly with not oriented rectangles, not rectangles that can be rotated like this, but just like AABBs, axis-aligned bounding boxes, but we didn't quite get there. As you can see, over the past week, I managed to get not only the axis-aligned bounding boxes, but also oriented rectangles, so both of these rectangles are rotated, and circles as well. What else? Oh, the editor plugin. So this is cool. In the editor, I extended the plugin, which is largely copy and pasted and modified, or not actually copy and pasted. It's largely reworked from the editor plugin built into Godot that does the normal shapes, but it's not actually copy and pasted. I retyped everything that I took because I wanted to make sure that I understood it. I didn't want to take any code that I didn't know how it worked, but that's what's adding these little handles here that lets us resize the collision shape right in the editor, and there's one for this circle too. So you can go. So that's there, and I'm happy about that. When I was working on the oriented rectangles, I made kind of a big change. So to rotate stuff, we need to do matrix math. And I was like, oh, well, I can do that. I mean, we'll have to have our own sine function and cosine function, but that's just like lookup tables. I can make up some lookup tables and you know, interpolate between like whatever values on this sine lookup table. And I sat down to do it on Saturday, I think, and I was just like, oh man, I don't want to deal with these tables and test them and make sure I didn't make any mistakes. So what I ended up doing was I grabbed this C fixed point math library called libfixmath, and they have, you know, all the trig functions. Where's the code for it? Should be in a third-party folder. Also MIT license, and I threw this in here. It has, when you go to the tables, its sine table is 200 KB worth of sine table data that I did not have to generate and I did not have to test. So I'm happy about that, and it's been working okay. Actually switching to using this library instead of my own bespoke fixed point math stuff was like a 30-minute change. So if we ever decide that this fixed point math library isn't going to work for us, it's easy enough to remove. Basically, I just took our fixed class, which we had before, and then just replaced my bespoke math functions with calls to these C functions, and then added all of the additional ones for trigonometry stuff. Let me show you that. So is this the vector? Yeah, that's the vector. Here's the actual type. So yeah, rather than, you know, doing my own math here, we just call this fixed 16 from int from float. When we get down to the addition and subtraction, you know, adding, of course, and subtracting are very, very simple in fixed point math. It really is just adding and subtracting. So some of these, like maybe even for performance reasons, we might not want to use the ones from the C library, but being able to do all of these trig functions is nice, not having to write that code. But there's an interesting follow-on effect to doing this. So if you remember from an earlier stream when I was explaining how we were doing our fixed point math, I said we were doing, and this is of course a terrible drawing because I only drew 4 dots for 21 bits here, but we were doing 10 bits of precision for the fractional part and 21 bits for the whole number, and then of course 1 bit at the top for the sine. And this fixed point math library does a different layout. It does 16 bits for the fractional part and 15 bits for the whole number part, with then 1 bit for the sine, which is probably fine-ish. I was a little worried with this format that I had planned before that 10 bits of fractional precision wasn't going to be enough for angles, because angles in radians are very small numbers. They're numbers from 0 to 2 times pi, which is like 6.8 something, whatever. And I was just worried that we wouldn't be able to be precise enough, but I figured I'd deal with that once we tried it and saw what happened. There's also like different binary representations for angles that I figured like maybe we could try that if it wasn't good enough, but then we'd have to have some way to kind of convert between this like binary representation that wasn't just like a straight fixed point number to like something that would work together with these fixed point. Anyway, so maybe it's a good thing that we switched to 16 bits of fractional precision, but there actually has been an interesting follow-on effect that I wasn't expecting with the whole number part switching from 21 to 16, although maybe we would have had the same problem with 21 bits of whole number. I'm not sure, but I will talk about that I guess right now. That's the next thing on my list. So last night I stayed up super late trying to debug this issue with circles. And circles are theoretically the simplest shape to do collision detection for, because you're just saying like, what is the distance of the points on this rectangle from the center of the circle, and is it less than the radius? So the actual code for that in C++, let me find it for you guys. So I have this now collision detector 2D internal class, which does all of the collision detection, and circles against AABBs. We'll look at that because it's the simplest. So we get the min and max point on the AABB, which means the top left corner and the bottom right corner. We figure out which one of those points is closest to the origin of the circle by doing this clamp thing. It's basically like we take the point of the circle and then say like, well, we can't go further left than the lowest x and further right than the maximum x, which puts us kind of at one of the sides of the rectangle, and then we do the same with y, which brings us to one of the corners. Anyway, it's a relatively efficient way to find out which point on the rectangle is closest to the circle. Then we get a line between the 2 points, which is really just a vector, and take the length and compare that to the radius of the circle. But you'll notice here, I have this length squared 64. So let me show you this other little demo scene that I've been doing, which we're going to be working on primarily today, where I can drive my my little tank icon around, and when it crosses into one of the shapes, it turns red when it collides, and that gives me like a way to more precisely sort of see that my collision is working. Anyway, so the collision was working in the other demo perfectly with circles, where I was bouncing back and forth and detecting the circle. But when I started driving the tank around, I noticed that driving over here, like where there's nothing, would register a collision. And it was driving me mad. I worked on it for, I don't know, an hour or two, and then like I was getting bleary-eyed and I couldn't keep my eyes open, and I was just like, I don't know, tomorrow on the stream I'm just going to delete the circle and we're going to just work on move and slide with the rectangle. So I turned off my computer and I started getting ready for bed, and like 5 minutes later this thought occurred to me, and I went to my computer and tried it, and sure enough it was the problem. So the problem is that reduced whole number precision. If you look at the math here, so finding the length of a line or a vector, which is basically the same thing in our context here, because we're not doing lines, we're doing like segments, line segments, is the Pythagorean theorem. So you're taking a squared plus b squared equals c squared, and c squared can get really big. You know, if because all of our numbers are times 65,536. Because that's what we're considering 1 in our fixed point math. So you take like a couple hundred, multiply it by 65,536, square it, and then add it to another number that is also a couple hundred times 65,536, and also square it. That number together is pretty big. And it turns out that when I was driving my little tank guy over here, the number was overflowing. We were running out of bits to hold a number that big, and it was causing really strange behavior. And it was so weird because it's like, well, the collision itself is working fine, like over here, but like, why is it colliding over there? And so what I ended up doing, the solution that I came up with was to add this length squared 64, which does the same thing, but it converts the numbers into 64-bit integers, and ends up making the result, the length squared, as a 64-bit integer, which we then compare to a 64-bit version of the radius squared, which is fine and works. But it's basically impossible without changing like our underlying fixed point math stuff to get a normal length, a not squared length, because the actual length is the length squared. Get the square root of that. But I think that the square root in libfixmath is done with another lookup table. I actually haven't checked. Let's go check. Let's go find out right now. How is square root implemented? So here's the square root method. Get the absolute value. It has a little optimization here for numbers that are less than a certain value. Ooh. It's not using a lookup table. It is not using a lookup table. So maybe I shouldn't be as worried as I am right now, because this thing got me worrying like about the whole premise. The whole premise of this deterministic physics engine is that we can do it with fixed point math. And this problem that I had yesterday made me start worrying like maybe we couldn't. So I think maybe we could, though. I think maybe we could. Since this square root does not involve a lookup table, we could write our own version of this square root function that deals with 64-bit numbers instead of these 32-bit numbers, and then actually calculate a square root that we could then put back into one of our smaller fixed point numbers with only the 15 bits of whole and 16 bits of fractional. Anyway, that's what I've been doing. And what we're going to be doing today is taking that and making it so that when we drive our tank here and run into these shapes, it won't let us run into them. It will do the move and slide that Godot usually does. So let me just show you the code here, which is pretty simple. You know, we're getting input, blah, 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 making a vector that I'm calling velocity for some reason. It's not really velocity. And then we are doing move and slide, which right now is just moving the character. We have to actually make it do the move and sliding. And the way that move and slide works in Godot's normal core code is by using move and collide. Let's actually just go look at that really quick. So kinematic body 2D, no. Oh, it's physics bodies. Physics body 2D. VS Code's making me type the whole thing. CPP, there we go. So that's move and collide. Let's go look at move and slide. Move and slide. So move and slide is relatively straightforward. What it is doing is it is calling in a loop a maximum number of times, this max slides, move and collide, and then it gets from move and collide some information about the collision, such as how much extra movement wasn't used and the normal of the collision, and it's using that to then move the kinematic body again and getting another collision, and then keeping doing that until either it reaches, you know, this max number of slides, or it's no longer colliding. So you can see, you know, this is how many lines was that? 1300 was that line number, down to 1226. So not that much, you know, 75-ish lines of, or no, here's the start of the method. So okay, 90 lines worth of stuff. And so basically, in order to implement move and slide, we're going to need to first implement our own version of move and collide. However, move and collide, here you see like just a little bit of code. This is because it's just calling into the physics engine, where the physics engine is then doing all of the work. Move and collide is a nightmare. It is pure madness in there. And that's no dig on the people who worked on it and the quality of the code. I use move and slide and move and collide in like basically all of my Godot projects, and I love those methods and they work great, but they cover a lot of use cases because Godot has a lot of use cases. That's very old code that has been worked and reworked over a long period of time, fixing bugs, addressing all of these various edge cases, and it is just really hard to look at and kind of figure out what it's doing. But I guess let me show you really quick, and then we will never look at that code again. That is scary code where dragons live. So let me find, that is actually in, it's one of the SW physics engine things. Let me kind of wander my way there. Okay, so it's body test motion on, I believe, physics 2D server SW CPP. Oh, which takes us into space. Okay, fine. In space 2D SW. This is the one. This is the one. Oh yeah, look at all that code. It's still going. Don't worry. Don't worry, it's not going to end anytime soon. It's still going. Okay, so that's a couple hundred lines of code, which is baffling. And we're not going to try and implement exactly what Godot is doing here. We're going to aim for something simpler. But it was looking at this code that I kind of like derived the algorithm that we're going to use, which I don't actually know how much of this algorithm is actually used in the Godot implementation. But it's what we're going to use, and we're going to try it. We're going to see if it works. So let me explain to you this algorithm. Let me get a new, or do I have a blank one? I do. Okay, so the algorithm we are going to use for our version of move and collide, as soon as it lets me write. All right, so we have the shape that we are going to collide with over here. This is the static body. And we have our tank, which we're just going to represent by a very poorly drawn rotated rectangle here. And let's say we are going to move and collide it to a proposed position of, say, here. All right, so we are going to first move the body here, check with the physics engine if it overlaps, and if it does, we're going to start doing this kind of binary search where, okay, so we know it collides here. Great. That is our, we'll call it high value. And then we know this, where it doesn't collide, because that's where we started, that is the low value. And so we'll say, okay, let's put this halfway in between. We'll move it here. And we'll say, okay, does it collide? Well, in this case, yes, it does collide again. So then we move our high value down to this other shape, or down to this other position, and our low value stays here. So we say, okay, we're going to move it halfway between those values. So we move it halfway between those values, those positions, and here it doesn't collide. Okay, so we now know our low value should actually be a little bit higher. And we'll just kind of move back and forth this low and high value a fixed number of times. I've arbitrarily chosen 8. I believe that might be what the Godot code has also arbitrarily chosen, but I'm not sure I'll be able to find that code in here again because this is just so messy. Best safe, best unsafe. That's, oh, here we go. Okay, so here's a high and low. Okay, this is where, out of that hundreds of lines of code method, this is what I latched onto. And yes, Godot is arbitrarily doing it in 8 steps. But what this will allow us to do is eventually we'll find the low value, which is where we will put the body ultimately. That is the position that will say, okay, we've collided, so this is where we're going to move it. And then we'll take the high value and we will get the collision data from that. And that is how we will get like what shape and what body did we collide with. That's where we will get the collision normal from. And I guess the difference between how much we traveled to get to the low value and the original length of the movement will tell us like how much movement we didn't make. And that will allow us to build up enough information to return from move and collide to then implement move and slide. Let me see if there's anything going on in chat here. The clean sees a lot of ifs in that code. All right, so hopefully that makes sense. Any questions so far? Any thoughts before we really dig in, before we start trying to make this happen? We'll get up to the place where we're going to be writing this code. We have our own version of a kinematic body. It is SG, what did I call it? Bodies, internal CPP? No. What did I call it? Oh, I think it's actually, I think it gets its own file. Right. So this is a node types that we're exposing, and for whatever reason I put all of those into their own files, and then a lot of the internal classes I just crunched them into their files all mixed up together. Maybe in the end I'll split them up. Anyway, so here we have our move and collide and move and slide declarations. For now, we're just going to have move and collide return a bool. Eventually we will need to return some kind of structure so you can get all of that data off about the collision so that move and slide can do its work. But just to start with, we want to get these collisions, get the correct high and low positions, and stop our tank from riding over our collision shapes. So let's get down to it. The clean says, instead of constant number of iterations, you can define a limit and stop when abs high-low is less than something. Yes. Yes, we could do that. I guess the question is, what is the value in doing that? Like, what are we losing by not being more precise? Like, not having a fixed value, and like, what does it gain us by switching? For now, like, I just want to do the fixed thing because like it's easy, and also I feel a little bit more confident in doing it because I know Godot is doing it. Godot has a fixed like 8 programmed in there. But yeah, let's experiment with this. We'll get an idea of like how this is good or bad, because like I don't really know yet, All right, so I wrote a little bit of pseudocode for this earlier. Let me actually bring that up. Although, no, whatever. We'll write it as we go. It's simple enough. It's simple enough. Let me get our characters back scrolling here. So what we want to do is we need to have a fixed point number. Well, okay, so there's going to be 2 fixed point numbers for the high and the low. And we're going to need to have one that describes our current position. Maybe, maybe not. But these are going to just be ratios of like how far on this linear velocity vector from 0 to 1. So this will be fixed 0. I made all of these fun little constants because I got sick of typing 65,536. And the current one, I guess we'll just put cur. We'll do something like that. So current will equal halfway between them, which is low plus high, right? Low plus high divided by 2. Is that right? Or is it high minus low? High minus low would give us, I think it's low plus high. Someone else can check my math and tell me I'm wrong, because I'm probably wrong. And we'll divide that by fixed point half, which I have not yet defined a constant for, but I really want a constant for that. Oh, I did high with. Let's go define that constant real quick. And we will essentially hard code the value by doing the math not on the computer. If we were to convert like from float 0.5 to a fixed using the actual like code running in the game, that could lead to the floating point math errors that we are doing this whole enterprise to avoid. So I'm just going to do 65,536 divided by 2. And what? Oh, I did 2K. I don't know why I did 2K. We don't need the decimal point. I would have cut it off anyway. All right. Fixed. And I should have known this number. This is another magic binary number that I should have had loaded in my brain from years of programmer brain. Jump back to where we were working here. All right, so that is our current position, which we will multiply. Well, that's our current ratio, which we're going to multiply against our linear velocity to get the position we are testing. Although, no. Before we do any of this, we have to first make sure that it collides at all. Okay, I skipped a step. So first, we need to take this kinematic body, its internal representation, which I think is, I do get internal, I think? No? How do I get the underlying body? Collision body. Internal. Okay, it's just internal. I don't have to get internal. It is just accessible to me. Okay, so this is our internal representation of the physics body. We are going to, I guess, make a copy of it. Should we make a copy of it, or should we save the transform and restore the transform? Let's save the transform and restore it later. So here, hang on. We'll do fixed transform 2D equals internal get transform. Oop, I gotta give it a variable name. So this will be like original transform. And we are going to get a new transform for it by adding the linear velocity to it. So we'll do internal set transform. We'll do original transform. We want to translate it to, or translated, does that add? I think it does. I think translated adds as opposed to just sets the translation. Let's go double check though. Oh, and I have to convert this to the internal version of that, but let me just quick check if this is adding or setting. It is adding, brilliant. Okay, so we translate this by the linear velocity. Of course, this SG fixed vector 2 is one of the objects exposed to Godot versus one of the internal objects we're using for our physics engine. So we need to get the internal thing, which I forget the method to do that. It's get internal. Beautiful. All right, so we are translating from this position to this position, and we need to make sure that the shapes associated with that kinematic body also move. This is making me regret a decision I made last night. Ooh, the clean says something. Easier to remember, but easier to eat. Add some zeros to the code and spend 2 days debugging. Oh, what is he saying? Oh, yeah. The clean recommends doing this in hex, which does actually, like, yeah, it is easier to remember what the hex is than the magic decimal numbers for sure. So maybe I should start doing that. I'm not sure. I'm going to stick with what I've got for now, but thank you for planting that in my head. I will be considering it from this point forward. Every time I type a magic number, I'll be like, should I do what the clean said? Should I make this hex? All right. We are translating this. What was I about to do? Oh, so last night I was working on... originally, I had it set up so that the only things that had transforms were the shapes, and the bodies themselves didn't actually have a transform, because I was like, what's the point? They just need to be in one place. But then I realized that the point is, or that they would be useful to be able to move the bodies without having to mess around with the shapes. But then I was doing the math with the shapes, and I was like, here, let me show you the... where is that? So we want to get to internal... Not bodies, shapes. I think. Yeah, so I set up the bodies and the shapes to have separate transforms, and then you would get the actual global transform of the shape by multiplying them. But then I was doing the math for the collision, and I was like, man, we have to get this global transform a lot. Like, it kind of sucks to you know, that we're multiplying these transforms together every single time we want to grab the global transform. So I set up this thing to cache it, to cache the global transform. And then this global xform dirty mark happens every time we update the transform or change its parent, which we're calling owner here, because this is kind of removed from the Godot node system where we have the idea of parents and children. But now I'm kind of regretting that, because we need a way to mark all of the shapes as dirty. What if we have that happen automatically? Hang on. So I'm updating the body. I'm updating the body's transform, which is this method, set transform. What if this set transform looped through all the shapes and marked all of the shapes as needing to update their X form? I think that's fine. We wouldn't want this to be inline then, because that's way too much code to inline. So let's make that a proper method that we're going to drop in the CPP file. And I like to keep these in the same order in the CPP as in the H. So let me see where that would be. I think that'd be before everything. Before add shape, certainly. Okay. So void SG collision object 2D internal set transform. And the transform is one of our internal fixed transform 2Ds. And I'm pretty sure I had that as a const reference to avoid an unnecessary copy. P transform. Okay, so we're going to set transform equals P transform, and then we're going to loop over the shapes. And the shapes are being stored in a list, which I'm not sure is the right data type, but I'm going to stick with it for the moment. So that would be a list of SG shape internal 2D element. Let's see if I can actually remember how these loops are constructed, because I never can remember. So front, and then we want to make sure E is still valid, and then E equals E. Oh, wait, hang on. And this is shapes, and this is a pointer. And then this is next. This may be the fastest I've ever typed one of those for loops. if it's right. It's probably not. Okay, so then we need to go to each of those shapes, and we need to set their this internal global xform dirty to true, which I think we can do because I believe that these classes are friends. They go to tea on Sunday. I don't know. They're friends in the C++ sense. I think so, at least. VS Code didn't complain at me. Yeah, I think they're friends because we need to do this thing here where we're setting the owner of the shape when it's added. Okay, yeah, I think that's good. So we are now setting the xform as dirty, which should then cause the collision to recalculate the xform from us having moved, set this new transform. Transform and xform are kind of like abbreviation. Xform is an abbreviation for transform, in case that was confusing to anyone. And now we should be able to test for collisions. So we need to see if this shape is overlapping any bodies, and I believe we do that on the world. I think. Let me find the world class. So the world class is what in our physics engine here is taking the place of space in the Godot core physics engine. It's like the thing that contains a bunch of collision bodies and shapes so that you're able to like loop over them and apply a set of rules to them. In Godot, spaces can also like change things, like change physical properties. So you could have like one space where friction is higher or lower. And that's like, in the engine, you would do that by placing an area that would then like change gravity or change the friction or something like that. We're not doing any of that. We just needed some kind of container to hold all of the shapes and bodies. So we want to do get overlapping bodies and see if anything overlaps. So we need a pointer to one of these guys. So I don't have to type this. I'm just going to copy and paste it. Go back to our kinematic body. Here we go. Kinematic body, 2D. Paste this type name. All right, so this would be overlapping bodies. And so we actually need the world. Let me make a local variable for the world, since I think we're going to be calling it a lot. So this would be SG world. No. Yes, it is SG world. I think I maybe just have to include it for me to get the fancy autocompletes from VS Code here. SG world 2D internal. Okay, so SG world 2D internal world, and it's a singleton, which probably it shouldn't be a singleton. Probably we should allow them to be created and then have like a default world that like things will get put into automatically. But in the course of just trying to get things thrown together quickly, I made it a singleton, and we're going to do get overlapping bodies on our internal body here. And why is it yelling at me? What doesn't it like about that? This is only configured to work with areas. Okay, so until a couple days ago, all we had were areas, and now we have bodies. And apparently I did not update this to work with other things. So get overlapping areas also only takes areas. I don't think there's any reason why both of those couldn't just take a generic collision object, because all we are doing with them is checking their shapes. So let's change this to take, rather than areas, SG collision object 2D internal, SG collision object internal, P object. P object. All right, updated the declaration. Now let's go update the definition. Okay, gotta update these other variable names. We'll say, I'm just gonna call it other, so I don't have to keep putting a name on there. P object overlaps P object other, and then we add other to the list. Object other, oops, that's P object other. Okay, does that look right? VS Code seems to think so. Oh, I just noticed on these I have the iterator being const, which I probably should in that other place that I typed that stuff out. Let me find my way back there. I thought I typed that loop correct on the first try, but I did not. I forgot one thing. Where was that loop? That was on... I've already forgotten where we did that. Let's go see. Let's go look in Git. That was in collision body 2D internal. So SG body's internal. Or no, it can't be. It could be const actually. This could be const. I was gonna say that it couldn't be const because we are setting global X form dirty here. But that's actually fine because we declared that property is mutable. But now that I'm looking at this, I don't think it's appropriate to say that it's const because we do clearly intend to change it. I think I'm going to leave that one as is. I'm going to leave that one as is. All right. Okay, so we should now be getting the overlapping bodies. And what we care about here is whether or not it collides. So we'll say if overlapping bodies dot size, or not dot size because it's a pointer, size is greater than 0. Actually, maybe we should address this as equals 0 because we can bail early if it's 0. So if overlapping bodies is size 0, we're going to do a little bookkeeping. We're going to delete this list that has been passed to us because the way that I implemented this API is you are responsible for freeing up this memory that you get from get overlapping bodies. And we should be good. Like we just moved the body from where it was to where we asked to move it, and we didn't collide with anything. So let's return true or false. Which makes the most sense for a collision? Move and collide. I think false. False because we did not collide. Collision did not happen. All right. So now that we know that we have collided, we can start to implement our little binary search that we talked about and I drew my terrible picture of. And how should that look? So we need to update to a new transform, which is the original transform translated by linear velocity times this curve value, this halfway point between high and low, which initially is going to be 0.5. Wait, I'm dividing by half? No, this should be times half. Times half. Yeah, which will divide by 2. We want all multiplications here. And then what we would want to do is test again if there are any collisions. And you know what? Like, we're going to keep having to deal with overlapping bodies, but we only actually care about the contents of that list once. But we're going to have to keep getting it and deleting this memory, and that sounds annoying and inefficient. Let's worry about that later. We probably do want to come up with a way to avoid allocating these lists and destroying them like over and over again in the course of this method, which we know we're going to be calling a lot. You know, it's what's going to control the movement of a lot of objects in the game. But for now, let's be inefficient. Let's be inefficient and hopefully correct, and we can become more efficient later. Okay, so we need to, in both cases, mem delete this, because we don't need the original list anymore. But I wouldn't mind reusing the same variable. So I'm going to like declare this at the top and hang on to it, and then I'm going to just assign it here. So that down here, we can use the same variable to get overlapping bodies again. And we need to say if we collide, which is basically if overlapping body's size is greater than 0, then if we collide, then we want to move the high value to match our cur value, right? Because we've collided, so now we're setting a new point at which we collide at. And if we don't collide, oh, again, I need to do that as a pointer. And if we don't collide, then we want to set the low value to equal cur, because this is another position that we are safe to move to without colliding. And at the end of this, we need to mem delete our overlapping bodies, although I think we need to invert that, actually. Because when this is all over, we do actually want the last, well, no, we want the last overlapping bodies, but only for the high point. The last iteration could actually be a low point. Well, we'll have to solve that problem, but not right away. That we will need to solve when we want to pass back the more detailed information from move and collide, because it's that last high point collision that will define what did we collide with and where. Okay, so this part needs to be in a loop. This is where we're going to do our fixed number of iterations. I equals 0, I is less than 8, I plus plus. And I do see that Cold Cardio, hey Cold Cardio, how's it going? Has said something in the chat, but I'll have to look over at my other screen to see what it is. Let me just finish typing this. All right, so then this should do our binary search that gets us to the right spot. Or no, because what if the last loop was low? Or I'm sorry, what if the last loop was high? So this wouldn't leave us at the right spot. So we actually need one more step here to set the end transform of our body to the safe place for it to be, which is the low value. And then we're going to return true because this had a collision. Does this look good to you guys? Does this look right compared to the algorithm I described earlier? I think so. Let's compile it. We're not using move and collide yet because the code still says that, but let's compile this. I want to close my old one here. Let's get this compiling, and then I'll see what everyone's saying in the chat. Probably yelling at me for doing something terribly wrong. Come on, Chromebook, you can do it. What's going on here? Cold Cardio says, love your work, brother. However, I got to sleep now. Oh, man, go get some sleep. Sleep's important. Take care of yourself. Anyway, thanks for saying. Catch you next time. All right. Let's see what we can do when this compiles. This is the annoying thing about streaming C++ is waiting for the compile times. What can we gossip about in the meantime? What's everyone else working on, guys? Like, what are you building? Where's your projects at? Let me know. Yeah, this runs extra slow because we are doing the debug version and we are running the debugger. I suppose I could like have some mode where I don't always run the debugger, but you don't know you need the debugger until you need the debugger, right? So I kind of like to have it always going. Okay, so we need to change our code to use move and collide rather than move and slide, even though we are eventually going to do move and slide. Character move and collide, our velocity, and I would like to print something out if it collides, just to get a little bit extra feedback in case it doesn't do what we expect, which there's a very high probability of that. What did I do wrong? Oh, I'm thinking Python 2 here, not GDScript. Put some parens around that function. Okay. Haven't crashed yet, but I'm not moving. Oh, here we go. Okay. Okay, so I can rotate, but moving forward and backward is oddly not working. I think... I wonder if it is working, but just isn't updating the visual representation. So I'm holding forward. Let's go look in the terminal. Yep, collides. I bet that's exactly what's happening. I'm updating its position in the physics engine, but not updating its position on screen. So, what can we do? Let's go look at the code. So we call this, and we're still in the node. So as we are in the node, we can kind of take the transform from here and set it to the node's kind of Godot-ish representation of the transform. We would say set internal. Do I have a set internal on fixed transform? If I don't, I should get one. Or why fixed transform 2D? No, not 2D. That's the type name. No. Okay, let me see. Or no. What? What am I thinking? I want to set fixed position based on the internal get transform get origin, right? And I can already see that this is going to lead to a memory copy. What did I do wrong here? No suitable user-defined. I need to wrap it. Oh my god, too much indirection. Indirection is what kills me all the time. Okay, so set fixed position. I think we want to update the internal fixed position if we can. Is that accessible to us? I just want to avoid too many memory copies, you know? Ah! C++. Memory management. Okay, so we cannot directly access the position, but we could get the position and change it, right? So does this have a thing where we can set the internal value? Set internal. Okay. Take 3 on writing this tiny line of code here. Get fixed position. Set internal. And we want to take this internals transform, although there's a copy there, and I already don't like that there's a copy there. So let's do it we'll say like final transform. We'll do a local variable here, which contains this. That's the position we want to end up at after we are done moving, the safe position that our body can rest at. And then we're going to do our final transform, get origin. There we go. So I got rid of that memory copy, I think. And that should theoretically update our visual position as well, because setting something on the fixed position object will trigger this change signal, which will feed everything back into the node. So let me close out our last version of Godot here, start compiling, and then take a look in chat, because I did see at least one comment. All right, compiling. Cold Cardio said, no, that we already talked about Cold Cardio. Spencer Peterson. Hey, Spencer Peterson. Thanks for coming. Yo, your Git videos came in clutch for me the last few weeks. Much love. Thanks, man. It's always great to hear that my tutorials are helpful for people. I'm glad the Git tutorial series has worked for you. Compiling, more compiling. This morning, Elliot and I were gossiping about changes in the Commander X16 project. I don't know if you guys are even into retro computers and retro consoles and that kind of stuff. There's this Commander X16 8-bit computer that's basically like a descendant of the Commodore 64. It's even going to include some of the code licensed from Commodore, from the Commodore 64 and I think 128 also. And there were some changes going on in the project, something me and Elliot are vigorously waiting for it to come out. Anyway, let's test this. Let's see what happens. So what we're looking to see is if I move forward, my tank should actually move. And it's still not! What? All right, time to bust out the debugger. It is saying collides, though. That's interesting. Is it just always colliding? That's a possibility, that it's not a matter of updating the visual representation, but it's just never letting us move because it's always thinking it's colliding. I have the terminal down here. We'll make a couple of new lines. I'll try moving forward, forward. Okay, so I was able to go a bunch of forwards without colliding. Now it's colliding every time I move forward. Now let me go back, colliding when I'm going back as well. Well, that's not right. Okay, let's debug this. We will start at the top, I think. And let's do up. That should trigger that to call, to come, to go, to run, something. Oddly, it is not stopping at my breakpoint. Sometimes I put breakpoints on lines that the computer can't actually break on, so I'm just going to put a bunch of other lines here, see what's going on. Okay. Did you guys see that desktop notification that came on over the window that's got the little guys on it? Ooh, a bunch of new people are bouncing around in here. Wave HD, welcome to the stream. I also see Arvid Schoenberg. Thanks for coming. What are you guys saying? How are you using C++ and Godot? Sorry if you already explained, I've just arrived on the stream. That's Wave HD and Arvin Schoenberg. I have a slight feeling I am late. Hi, Arvin. Yeah, you're a little bit late. We had a slow start because the stream crashed. Sorry about that. Oh, thanks for letting me know that the notification isn't appearing there. That's fantastic. So to Wave HD's question, how am I using C++ and Godot? So the Godot engine is written in C++, and there are at least 2 ways to use C++ in the code for your project that are officially supported. Godot you can use with a plethora of languages, like GDScript is built in, C# is built in, Visual Script is built in, and so is C and C++. So we are writing a Godot module that gets compiled into Godot itself. So we have to recompile Godot for our game, but I've CI set up to do that for me automatically, so I don't really have to worry about it too much now that I've finally got that working. And then also you can make a GD native plugin to write C or C++ code for your project. But GD native is kind of, I don't know, it's kind of a hassle to work in. It's best if you're doing gameplay code in C++, where we're not really writing gameplay code in C++. We're writing a new physics engine to add to Godot to do this network deterministic physics. Okay, so only using GDScript to answer the C++ question. I'm not entirely sure what you mean by that. You're only using GDScript? Or anyway, let's try and figure out why the debugger isn't triggering here. Move and collide, which we are clearly calling. Move and collide. We're binding it to the right method. Am I accidentally calling move and slide or something? Huh. It's telling it, no, it's telling us collides, so we must be, well, something we are calling is returning true. We're calling move and collide, which is bound here to move and collide, which this is move and collide. Why the heck is our debugger not stopping? Oh, I know why. Dumb mistake. Because we ran this from the editor. All right, let's get out of here. When you launch the editor, that is the process that is running in the debugger. But when it then launches the game, that's a new process, which is not in the debugger. So we need to quickly switch to launching our test directly rather than launching the editor. So let's get that going. You know, GDScript is a great way to use the Godot engine. You can just iterate so fast. It's been like a huge adjustment for me switching to doing all this stuff in C++ with just how slow my progress is. It's like I sit down to do something and like, you know, an hour later I get something done that if I was just working in pure GDScript, I would have had done in, 10 minutes. All right, so we have some additional breakpoints here that we don't want it to break on. That was, when I was debugging some other stuff, I guess. And we also don't want it to break every time I am moving towards this rectangle. What I'm going to do is I'm going to disable the breakpoints. I'm going to keep pressing up until I see it say collides. All right, and then I am going to re-enable those breakpoints and move up one more time. All right, here we go. The debugger has activated. And let's start stepping through this. All right, so we're getting the original transform from our body. We are then setting the transform on it, getting overlapping bodies. Let's quick take a look at the memory here. That is not useful. So this is a linked list size cache. I guess that's probably the size. So let's see if it steps into, nope. Okay, so we step over. We do have a collision. We have our high and our low. We're going to do our 8 iterations here. High plus low divided by times half, so that should get us 0.5 in our fixed point numbers. Let me just verify that. Go to cur value. Yep. Okay, so that is 0.5. We are going to translate by this linear velocity. So I just started thinking something. Because we can't see what's happening, which is still weird. Like we definitely should be able to see what's happening. Oh, when we return here, when we return early, we are not doing this stuff. Okay. I bet that's why we're not seeing it. Anyway, the thought that I had that I'm worried about this debugging session, because we're not seeing it, we actually don't know if the object didn't pass inside of the other object. And because we don't know that, debugging this particular call of this method might actually not give us some useful information. So hang on, let's first, the thing that I realized, which is that we need this method to happen before we return. And we don't have final transform. We just have the internal transform we'll have to get the data from. So we'll say internal get transform get origin. And let's recompile and start over. Let's what are all these other breakpoints? Let's delete these. Delete you. Let's disable the breakpoints. Let's recompile and start over now that I've realized that when we are exiting early, we are not we're not updating our visual position. So let's try that. What's going on in chat? Network physics seems tricky. Been following the devs of Sir Happenlance. I'm not familiar with Sir Happenlance. Feel free to drop a link. That's not something I've heard about. Following him on Twitch, and it's way over my head. Yeah, network physics is tricky. Luckily for this game, the amount of physics is actually super minimal. So I'm hoping we'll be able to, actually like next week, hopefully, have the game actually be playable on this physics engine to some degree, playable, insanely buggy. The clean, my wild guess is that visual's not updating, but Collider is. Yes, I believe you are correct. That is also my guess. Arvid Schoenberg, finally someone using an actual debugger. Too many people always print out debug messages to the terminal. So I also sometimes print out debug messages to the terminal. In C++, you kind of don't have that as much of a viable option because you'd have to like recompile every time you're updating your debug stuff. Oh, what the heck? So what the heck? Okay, so I'm gonna put some space here so we can see what happened. I'm gonna back up a bunch. I'm gonna put some more space. Back up a bunch more. It still says we're colliding. We're like always colliding. Let me just restart this. What I care about right now is not the collision case, it's the non-collision case. I want to get this non-collision case right. Oh, another thought occurred to me. I wonder if this set internal bypasses the changed logic. It totally does. Okay. So we need a way to set the internal, but like still trigger the change logic. We have a set x, set y. I'm like trying to get way too clever with this. Okay, back to the drawing board. So we have our new position, and what we want to trigger is this code. But we ideally want to do it without having to create a dummy object, like this is dynamically allocated memory, just to do it. How can we get all of this stuff to happen? Or really this stuff. Maybe we need an internal method. Or we need a set transform internal method. Let's make a new internal method that's setting a transform, because I have a feeling we're going to want to do this different times. There may be different reasons that we're setting a transform. It's not always going to be because we are changing the position. We want all of the things to update. So let's make a protected method. And we're going to call it not set fixed transform because I make way too many set methods that are kind of like magical. We'll call this update fixed transform. And it will be take a const fixed transform 2D reference. And I think this is complicated enough that we don't want to inline it. Let's go over here. It should come after get global transform. Say void sg fixed node 2D update fixed transform. I don't know why it's not. Oh, there we go. Now it's auto completing for me. Fixed transform 2D p transform. Okay, so we want the internal transform to change. So we're gonna start by doing this like latch flag thing here we have, which is avoiding an infinite loop. Or hang on, updating. We set this so that when we update the fixed position and it updates the visual position, that doesn't in turn update the fixed position, which actually only happens in the editor, but the code can run anywhere, including in the editor potentially. So okay, we want to wrap it in that. We want to say fixed transform equals this new transform. And then we want to update all of the Godot visual stuff to match that transform. So this would be hang on, we also need to update these like other variables. This could change everything. Okay. All right. Let's update the transform. And I think we still have to call the set fixed position and set fixed scale and all of these methods. Or at least update these objects too. Now I'm regretting my update fixed transform method that maybe we do just need some like magical internal method to say like update fixed position based on all right. I'm gonna type this whole thing to the end, and we will look at it in the end and decide whether it makes sense or not. So fixed position, we need to set the internal based on fixed transform, get origins. This will update the position if that changed. And we need to set the fixed scale to set internal. We need to grab from the fixed transform, get scale. And we need to, why did that not work? What are you yelling at me about here? Oh, I forgot a semicolon. Too much language bouncing back and forth. All right, and then what is the other one? Rotation. Fixed rotation will equal, because that's just a single number, fixed transform get rotation. And then we need to trigger all of the set methods like, why didn't this work? Is it angle? Oh, interesting. From fixed to int. Oh, because it's internally we're keeping it as an integer. Okay. I already don't like this. I already don't like this. Let me see if anyone's got some smart suggestions in here. Want to become famous? Yeah, that's why we don't print out those things on the on the screen. Yeah, there's actually there's a news story I heard about like a dramatic influx of Twitch bots that show up and say racist things. So I'm glad that we don't just show anybody's messages on the screen. You have to join the Discord, which is the link this-ish way, one of the ways towards the bottom of the screen. And if you go on the stream channel and post there, then your messages will appear on the screen. And now I need a button to get rid of this 4ZX William Tell guy from our, happy crew of bouncing characters. We'll have to add that in another stream. All right. I'm already not liking this method. I'm gonna comment it out. I hate to delete it because like in 2 minutes I could come back and like redecide that that's a good idea. So I'm just gonna comment it out. Let's look back at what we're doing and see if there is like a easy way to do what we want to do. Anytime I end up writing too much code for something that could be simple, I just like get suspicious of the whole thing and decide like maybe I just need to rethink it. So okay, we're setting, if we do set fixed position get fixed position, what is returned by set internal? Let's just do this like a super naive way and we can improve it. So this should trigger all the stuff we want to trigger. And I guess, yeah, we already have the other one. Without allocating any more memory. No more memory is being allocated. Let's try this. Why is this not even showing? We might have to kill it. Oh, because the debugger's running. Compiling. Ross says, oh yeah, do you have to worry about the usernames themselves, or do various platforms have profanity filters? You know, I did think about that. I think for the most part, it's hard enough to change your username that like maybe that will save us. I guess I'll say that until the day that we get some disturbing usernames. But like on Facebook, you know, they make sure your username is your name. On you know, YouTube, you're using that username for lots of things. Probably isn't something offensive just to mess with streamers. But I could see on Twitch. People making offensive usernames since they're making up crazy, you know, numbers and letters usernames for their bots. Anyway, all right, the moment of truth. Oh, it's moving us in the totally wrong directions. Whoa. So what's going on there? What is going on there? Oh, I think I know what it is. The transform on the physics object is a global transform, and the position on the node is local. So we could subtract the global position from the internal position, or subtract it from the position that we get, and then that should be the local position. Man, this is just turning into like a messy bunch of lines. I hope we find a way to refactor this soon. Well, I just want it to work. So got to subtract the global position, which has to be calculated by a recursive function, which sucks. Okay, what's a smarter way to do this? I think what... Ooh, I was just bringed. Thank you, whoever just subscribed. I think we need, because, okay, for a lot of these things, we're going to be taking the physics body and saying, okay, take whatever happened to the physics body and reapply it to the node. And that's a thing we're going to need to do a lot, just throughout. So I think what we need is some method on our collision body 2D node type here that will do that, because it has the internal object. It can say, it can be sync from physics engine, which is just going to be this internal protected method. Maybe it makes sense to make it external. I don't know. Certainly right now I'm more inclined to keep things private. And I'm just going to write this method, and I don't care how inefficient it is. I want it to work so that we can move on to the next thing. So sync from physics engine, and it cannot be const. Did I actually make it const? I shouldn't have if I did. I did. All right. So we know that the physics engine has the global position, and we need to get the local position. And so how do we get that? We get our global fixed transform, and we subtract... Hang on, we need to do more than that, because the transform could have scale and rotation in it. So, okay, we're going to say fixed transform 2D. This is going to be the physics transform, which is going to be from the internal physics object get transform, and that is a global transform. And so to take that global transform and turn it into a local transform, we have to multiply our parent's global transform, the inverse of our parent's global transform. Right? Let's try it. Let's try it. Let's see what happens. So we need to get our parents global transforms. This will be parent transform. Will be get parent. We need to do some special magic to get the parent as a fixed node 2D, because it might not be. Do we have a method for that on our fixed node 2D? I know that we do this somewhere in here. Okay, yeah, we do it in this method, in fact. Okay, so we'll do basically the same thing. So physics transform, then we need to get the fixed parent, and we'll say if so if there is no fixed parent, if fixed parent does not exist, if our parent is not a fixed node 2D, then whatever the transform we get back is fine. We can assign that to our transform, and we are going to need this update transform method that I started writing and then abandoned. Update fixed transform. We're going to take the physics transform, and that's cool. And we will return. But if we do have a parent, we need to get their global transform. So fixed parent, their global translation. No. Get global. Is it get global fixed? Get global fixed transform. And we will update the fixed transform by, so I did a bunch of these like global to local things in the collision detection, because the way we're doing the oriented rectangles is we're actually transforming whatever we're checking the collision against into local space of the oriented rectangle. So the oriented rectangle ends up being just an AABB tested against whatever the thing it's testing against. I hope that makes sense. And so let's take that code. So we're taking, when we do this for oriented rectangle against oriented rectangle, or let's look at one that aren't both rectangles. Okay, so when we're doing with the circle, we're taking the thing we want to be in local space of, getting the affine inverse and multiplying it by the global. So okay, the reason I'm checking this is because I was trying to figure out what the order is. The order of multiplying matrices is tricky, but it's even trickier when you're thinking about how you're inverting things, right? At least it is for me. I don't know if you guys have like a cool rule of thumb or something when dealing with matrix multiplication. So okay, we want to take the parent transform. We want to get its affine inverse, or what does the method do that? Affine inverse. Yeah, because that generates a new one. And we want to multiply that by the physics transform. Yeah? Does that work? Despite all the typos? So this function doesn't exist. Fine. Global fixed transform is not accessible. Oh. Okay. So we are a collision object 2D, and that is on fixed node 2D, which we are descended from, and it's protected, but I guess we can't call it on another object. Okay, so let's, I guess we have to make these public, unfortunately. Unless we just want to make them be friends. Let's make them be friends. I like friends. Everybody likes friends. So I'll say friend SG. So that would be collision. Wait. Why are we doing this on collision object 2D again? Okay, because it's the one that knows about the physics things. Okay, okay. Collision object 2D, and so we don't end up with a circular reference, we are going to forward declare the collision object to D class. Cool. So now that should stop complaining at us about that one, and now we have to still implement this method. So it was a good thing I didn't delete it. I knew I might need it. Where did I put that? Okay, let's get the declaration. And I always just like put myself into these endless like decision loops by worrying about the performance of things and like how many memory copies there are and whatever. Screw that. We are going to do this in the most inefficient way probably. We're going to call each of these setters and that will actually update our fixed transform, so maybe we don't even need to update that, but or no, not set position. Okay, this is gonna hopefully work even if it's terribly ugly. Set fixed scale, set fixed rotation, and maybe even like off stream, I'll try to figure out the right way to refactor this so that we're not doing anything quite this ugly. There has to be like some way to have like an underlying set of methods that I can call that will trigger the things we want to, but not do anything wasteful with memory or doing more than we want them to. Fixed rotation. And actually, we don't, oh, whatever. I'm not optimizing. Stop optimizing, David. Stop it. Okay. Okay. So let's go back to where we were. Let's figure this out. Where were we? Kinematic body. We have done the thing, and then we need to sync from physics engine. And then down here, we have done the thing, and now we need to sync from physics engine. And hopefully this compiles. I'm going to see what's going on in chat, but I want to make sure this compiles first, because if there's any compiler errors, I want to address them right away. Okay, linking. Linking always takes the longest. All right, what's going on in chat? Litmus Zest. That's a cool username. Thanks for joining. The clean matrix math is not commutative. I do not touch it without a piece of paper. Yeah, yeah. Matrix math is confusing, particularly because like the order matters, but then the order is also backwards. You know what I mean? Like the thing that you are moving is moved by its antecedent, by the thing you're multiplying first, which, so you always have to think, okay, I'm doing this backwards. But then when you're doing like cumulatively assembling matrices, you actually do it the other way around. You do it the parents, then the children, which makes sense. Like it is still the first way around, right? It's not the other way around. But in my mind, it's the other way around, right? Anyway, let's see if this worked. No, we're still crazy. We're still going crazy here. Why is that so zany? Well, we're moving. We're moving. So I have to figure out, why are we moving wrong? Oh, interestingly though, even though we're moving weird, and our collision like is not stopping us from moving, the bodies are like in the places we expect them to be. So this is the actual position of that body, but it's just wrong. It's just wrong. Let me look at the code. Oh, we didn't open it in the editor. I guess here, I'll just open it in Vim really quick. Test 2D GD. So it's the same thing. We just switched from our old move and slide, which just added to the vector, or added to the position, to this move and collide with the same value. So it's definitely a problem in the C++ code. I have this feeling that like translated isn't doing exactly what I'm thinking it's doing. Don't know why I'm thinking that. Let me go look in here. So translate. So what we want to happen is we just want to add this translation to elements 2. What is basis X form doing for us? Okay. Do we want that? Is that good? I want to see if there is another thing that is setting elements 2 that might be more helpful for us. Why did that not work? Probably it didn't like me putting the... Or, hang on, elements 2. So invert, affine invert. Times equals invert, affine invert. Are we just, have we looped? Have we gone back around? Yeah, I think so. Don't know what this basis X form is doing for us, but like we literally just want to add these values together. Maybe I'll just do that. Can I? Forget if we're allowed to write to those elements or not, the way that they're implemented. Let's go back to our kinematic body class here. And we're going to do original transform. Well, we don't want to mess with the original transform because we want, we're going to need to come back to that a bunch of times because we're translating it like here again. What if I just temporarily changed the transform class to simply add those rather than doing that basis X form, which I'm not entirely clear on the math reason that we need that. If anyone knows, please let me know. Okay, so we're just gonna add P translation. Because that's what we want to do. Wait, do we have a set origin? Can we do like get origin, set origin? I didn't look at the inlined methods to see if there was something here that... Yes, so we can do get origin, set origin. Let me just scroll through these methods really quick. Well, whatever. I'm sticking with the thing I'm going to try, which is just oh, I hope I was testing the right copy. I had a couple of copies of Godot running. I'm just going to try where we temporarily make that do a different thing. And let me just make sure I didn't change anything else in the kinematic body class. I don't think I did. Okay, let's compile it. Our Burring's character drank too much and is hugging a wall hard. Where is he? Oh my gosh! Our Burring, you're up there, just vibrating against the roof. You know, I had my character get stuck up there earlier. I wonder what exactly is causing that. So we have it, the code that we wrote for those characters bouncing around has them checking what they've run into and then sending them back the same amount. I wonder if it was like a floating point thing where you're like just barely over the edge such that moving back down like won't actually unstuck you from the wall. Quirdium. Hey, I was wondering why default physics body isn't recommended for rollback. So the reason is that Godot's built-in physics engine, we're moving correctly-ish. Oh, there's a circle there that we can't see. That's why it's doing it. Okay, what the heck? Okay, sorry, I got so distracted. What was the question? Oh, the Godot built-in physics engine is using floating point math, which is not deterministic across systems. If you are using the exact same binary on the exact same architecture with the exact same operating system, then it probably is deterministic, probably. But if any of those are switched, like you're having a Mac play with a Windows machine, or different versions of the same OS or whatever, like the math libraries can be different or whatever, the result won't be deterministic. And rollback netcode depends on being able to do the exact same thing on all the clients and have the exact same results. So you need deterministic physics. And the physics engine that we're building here uses fixed point math instead of floating point math to try and solve that problem. Anyway, what are we gonna do here? Like, so, okay. What's going on that I can't just use the normal translated method? Okay, well, let's ignore that for a moment. Let's ignore that we had to hack the transform object to make it move right. I'll figure that out later. We're running out of time here. Let's see if we can't get this move and collide working. So, okay. It says collides. I'm going to move where we're not colliding, and it says collides anyway. I'm not colliding at all down here, and it's saying collides. Which is weird, because clearly our other code that's checking for collisions is working. It's turning us red. But this thing's just thinking we're colliding all the time. What's going wrong there? Let me just set some breakpoints here and poke into that code. We enable our breakpoints. All right, so here we come into move and collide. And let's jump over those. We get the original transform, which I'm just going to take a peek at to see what the position part of the matrix is. All right, those values are so hard to wrap my mind around because of our fixed point math, but we are translating by the linear velocity that was passed to us. We're getting overlapping bodies. We are seeing if there are any colliding. So let's step over and see. I guess it always thinks there are overlapping bodies. I wonder why that is. Let me look in the that list there and see what we're getting. So size cache, okay, great. And I guess we do have a single value on here. What is it? I guess it's hard to tell. Because we just have a memory address. What is it that it thinks we're colliding with? I'm going to So okay, in our code, our GDScript code that we have here, later we are calling get overlapping bodies, which works fine. when we call it here. But for some reason is always giving us a collision when we're calling it inside a mooncloud. Also notice too that I have this overlapping bodies equals character thing, which I wonder if this is returning more results that we're just not seeing. Okay, I might step through the get overlapping bodies just to try and see if something's going wrong in there. So let's skip through this. No, I don't want this one. I want this only when it happens. Oh, and it's just gonna keep happening. Okay, let's trigger a break, and then I'll set the breakpoint. Okay, so move, we'll break, and then I want to go back to that file. Get overlapping bodies because I want to just send it to here. All right. Wait. Why did we get here like right away? I clicked a thing without thinking about it. Okay, start this over. Move. We broke. We're on the breakpoint. Then I'm going to go back into get overlapping bodies. I'm going to set a breakpoint here, and I'm not pressing continue. I'm coming back here. Okay. We'll step over till we get to here. Now we are in get overlapping bodies. Okay. And we are looping over these bodies. So I see other. This is the body we're testing against. We are colliding with ourselves. We are colliding with ourselves. Oh my gosh. Okay, so I had a code to detect that in the get overlapping areas method, but not in here because I originally wrote this code just for areas. And I'm thinking a area that's calling get overlapping bodies can't collide with itself because it's an area. We're totally colliding with ourselves. I didn't actually see that in memory. I just like looked at the code and thought that that's what's happening, but it must be. So let me just make sure. So if P object has the same address as other, then the collision is with ourselves. So 9941290, other 9941290. We're colliding with ourselves. Jeez. I always make stupid mistakes like that. Okay, so let's kill this. I'm just gonna hit the button to kill it and recompile and see what happens here. Let me see what's going on in chat. What's happening, RN, with the squares? Are you talking about the peeps moving around there? I'm not sure what you mean. I guess I didn't see it when you said it. Gulliver Jaham, welcome to the stream. Thanks for coming. Hey, Snowpeck, did you see Carbone 13's repo? They're porting your system to C#. Yes, I did. I can't remember if Carbone is Lucas or if Lucas is working with Carbone, but I believe that is Lucas's work in some form, and he sometimes comes to the stream. And this is a new question about how are you using C++ with Godot? Someone asked that earlier. Was that someone else who asked, or am I like seeing repeat messages? Anyway, it's definitely possible to use C++ with Godot. It's one of the supported languages. We are doing it by making a Godot module as opposed to using GD native, which is the other way to use C++ with Godot. We're doing it as a module because that is much easier for systems, like making a separate physics engine, as we are. I want to disable all these breakpoints. All right. So now we're driving around normal. And, okay. We're not getting collisions, though. What? Okay. Let's look at this code I added here. Other equals object continue, overlaps object other, pushback other. That all looks correct here. Let's turn on our breakpoints again. So now we are moving. We're saying get overlapping bodies, and we are apparently always getting 0 and returning false. Okay, so we were supposed to get 0 here. Let's move to a place where we should not get 0, and then we'll step through it with the debugger again. So 1 step forward, and I should hit that box. So let's go 1 step forward. All right, move and collide. We will step over, step over, step over, step over, and then let's step into. So we know that this translated is doing the right thing because sync from physics is updating it correctly. And we know that get overlapping bodies, when called later, is working because we're turning red. So why is get overlapping bodies not working here? That is the question we're trying to answer. Let us step into. That should take us down here. And we're expecting to collide with an area. I guess I want to step into overlaps. I'll be able to do that with the button though. So let's step over, step over, step over. Let's look at what it's saying we're going to collide with. A rectangle. So it is testing us against a body that has a rectangle and a rectangle. I would have expected it to have a circle. Well, that's interesting that first and last are both. Well, whatever. We'll step through it. We'll see if that's for real as we go here. So, oh no, because this first object is us. Okay, this first object is us, which is going to get continue. Cool. That worked. Ah! There's no other bodies? Those are still areas. Those are still areas. Holy cow. Look at the litany of dumb mistakes I'm making today. You guys are supposed to be checking me. You guys are supposed to be checking my work. Oh, jeez. Let me kill this. We're going to disable our breakpoints. We are going to switch to running this in the editor, and we are going to change those shapes from areas to static bodies, to our version of static bodies. And while that is happening, let me look in here. Hey, Ricardo got it. The self-collision, you totally got it before before I saw it. Self-collision was totally the answer. QWERTY him 513, red and green squares on the tank. Oh, okay. So I'm just using a dumb icon for this test project and having it turn red when it collides as a way to test the collision. So here we go. This is where we all went wrong. This area, clearly named area, is an area, and we need it to be a static body. So let's go to change type to an SG static body 2D. That is our version of the static body. God willing, this will just work. Everyone cross their fingers. We're hitting problem. Oh, okay, because yeah, this code will no longer work because it's no longer an area. So, okay, that's not a problem. Redone, we're good. Come on, come on, come on. Okay, we're moving. We have stopped. We have crashed. Oh, no, we have not. We crashed once and then bust through. We're slowly busting through. Oh. How about... Yeah, okay. Interesting. So, some rounding problem, I would guess. As we're multiplying by 0.5, we're getting closer and closer, and sometimes we just go over. Now I'm just going through all the time. What about the circle? The circle? Ooh, and we busted through again. Interesting. Okay, well, we are now down to basically working on the code we were intending to be working on. So that's progress. That is progress. How much time do we have? Oh no, 5 minutes. Let's see if we can figure this out in our last 5 minutes. Otherwise, I think we're in a good place. We're steadily heading towards the direction of collision here. We're on a collision course with collision. It's a bad joke. All right, SG kinematic body. Okay, so we're doing our high-low thing. High-low fixed times half. Does this seem right? Let's I guess, yeah, I'll have to relaunch it so that we're debugging the app and not the editor. But let's get in there. Let's get in there and debug. Okay. Close you. Close you. Close you. And we're going to launch, change our launcher JSON here. We're going to launch directly our test app. What's going on in here? I can't even begin to comprehend GGPO code. No big brain, honestly. If you can even figure this out, the project extremely so the GGPO stuff I'm good at. I'm good at network code. Physics code and all of this math is tricky. Is super tricky. What I need to find is okay, I'm hitting my breakpoint. I need to find someone who's like good at the math stuff and like I can handle the GGPO end, the networking end. So I have that more or less working, but anyway, what I want to do is get us into a position where the next move is going to collide us. We'll head sort of straight on, so that will hopefully be a more direct collision. Okay, hopefully the next time I press up, it's going to collide us. Oh, and I didn't disable the breakpoints or anything, so okay. So that means we moved and we got a collision. Now, we are going through this stuff here, and the main thing I'm worried about at this moment that the curve value looks correct. So let's step into here. The first curve value should come out to be exactly half, which is 32,768, right? 32,768. And we'll check. Okay, we're going to update this this one. I actually would expect that this should still collide. That's what I'm expecting to happen. So we set the physics body to be at this halfway position. And getting the overlapping bodies. If we are colliding, right, if the bodies is greater than 0, it says it's not colliding. Quite interesting. All right, let's keep stepping, see what we get for the next time around. So now this should be 32,768 plus whatever half of that is. So let's make sure that that's right. That looks right, honestly. Or no. Wait, hang on. So we didn't collide, which means we're moving the low up. Right? Okay, so we didn't collide, so we should be moving low up. What is low? Right. So we shouldn't get a value. We shouldn't get a value that's less than low. How is cur less than low? We should get a value that's between the new low and high. Okay, So low plus high, which high should still be, why is high 0? I reversed these. Oh my gosh. I need to hire like a pair programmer to look over my shoulder, which honestly, I mean, you guys are looking over my shoulders. Sorry. I should stop making the joke that you guys should be checking my work, but that's totally a problem there. That is the problem. That is why we weren't getting the values that we expected. So low is supposed to be 0, high is supposed to be 1. All right, let's kill this, recompile, go away terminal. Let me see what's going on in chat. Yeah, Litmus Zest, that's a great idea. Change the name from area too, so I'm not confused in the future. I definitely should do that for sure when I get in there. Aknakos, today I'll not have the time to be here, but have a great stream. Oh, well, stream is coming to the end, but you can definitely check it out on YouTube, but you wanted to ask something. He's going to be teaching data science this year. I'd love to include some Godot in it, but I need ideas. Let me know if anyone, including chat, has any. Oh, that's so cool. Doing Godot in a data science class, that sounds awesome. I don't have any ideas right now, but I'll definitely try to think of some and maybe send you later. I'm very much looking forward to seeing what chat says. Yeah, some interactive data visualization. Godot is great for that kind of stuff, particularly if you write like a shader for it. Okay. We crashed right into it. Oh, we can turn sideways into it though. That's a problem. Oh my gosh. So straight on, head-on collision, it stops us. Yeah, so when we are rotating, we are not calling move and slide or move and collide, which I think we need to. I think we need to call it like, how would we even do that? I guess I need to look at how the current game handles this. Does the current game let you like rotate your corners into objects? Anyway, I definitely cannot crash into this thing, no matter how much I hold forward. I'm holding forward like crazy. I'm holding forward like crazy. It's not crashing in there. Let's go see the circle. Oops, am I going to be able to get out of here? I guess I have to go backwards. And I can't turn while moving. I guess I made a mistake in the... So the circle's over here. We can't see it because the collision shapes are turned off because we didn't launch it in the editor. But there we go, guys. I can go back and forth between the two things. Let's launch the editor just so we can see it, and I can make that that change that Litmus Zest recommended with having renaming that that node. Let's launch the editor. Oh, I'm so happy. I mean, this stream was a comedy of dumb errors on my part, which honestly is probably partly a product of being on the stream, because I do get a little nervous when I'm on the stream. I do think less clearly. But like, wow, I'm so happy at the last minute we pulled it together, guys. Good work, team. Oh man, it feels so good to come to the end of the stream and have something that's working. We don't have move and slide. We don't have move and slide, but we have the beginning of move and collide. And if I spend some time refactoring those setter methods so they're not quite as insane, I figure out a way to update the transform that works the way we expect. Can grab the collision data from the one collision that happens, and then we can pass that to move and slide, which is actually relatively simple compared to move and collide. Move and slide is much easier to wrap one's mind around, at least in my opinion. There we go. Crashing right into that circle. Of course, I can rotate into it. I need to look at what happens in the released version of the game when we rotate our corners into something. I have a feeling that there is some function in Godot that will sort of like push us out of the inside of a body if we start out stuck inside of a body. With move and collide. And the reason that I think that is because there was a comment about that in the code for move and collide in Godot. And so maybe I need to spend a little time looking at that. Here, we're going to end the stream super soon, but a couple last things I want to investigate here. where was that? That was in test body motion. Test body motion. There is a, oh, I guess it's in space. Okay, get over to space. There's a whole section at the front of here. It says step 1, free body if stuck. And that is why I have a feeling there is some process going on here that is trying to like push the body outside of a shape that it might be stuck in. And looking at this code right now, skimming it, like I am not sure what it's doing. I'll need to spend a lot more time trying to figure out what's going on here. But maybe that's what I need. But yeah, guys, we are out of time, a little bit over time even. Thanks so much for coming to the stream. This was a good one despite all of my dumb errors. And let's see what's in chat before we sign off here, before I sign off here. Maybe a Boolean param for allowing rotations? Yeah, the thing with rotations is, so the way that we set up move and slide to work is we're moving, and then if we can't move there, we move back. But with the rotation, we aren't really moving. Although I guess, hey, we could have a rotate and collide method, where we rotate rather than translating, and then ease our rotation back using the same algorithm, that same binary search. That's an idea that we could do. Thanks for suggesting that. QWERTYHim513. Comedy of errors describes most of my coding sessions. Probably that's true for me too. I think so. Hopefully it's a fun comedy, and then people will come to the stream. In Godot, the move and slide and move and collide work as intended, but the general physics with just physics doesn't. Objects go inside themselves and tremble, so don't port that much code. So yeah, you know, I've had decent experience with rigid bodies in Godot, but yeah, there's physics is a fraught topic, and I've definitely also had problems with rigid bodies in Godot too. I've had them be successful, and I've had them have problems. Luckily for this game, we're not doing any rigid body physics. We're just doing static bodies, kinematic bodies, areas, and raycasts. So if we can implement those 4 things with a whopping 2 shapes, if we're not counting array as a shape, of just rectangles and circles, and then we should be able to implement everything in Retro Tank Party, which is going to be awesome. So yeah, thanks again, guys. If you want to stay in touch, go join the Discord. I will be sharing my progress between this week and next week's stream there as I go. And yeah, looking forward to seeing you next time. Bye-bye.